very helpful. Good reminders for everybody.
I've actually never done one of these, like in real life. Every time that I go to start doing it, I find my mistake on my own.
Right.
So
Right. Which is
I've never had to post one.
super helpful.
I think we should.
What do you guys think, Martha? Should we start? Should we wait a few minutes? It's 12:10.
Yeah.
It's really up to you.
Yeah, it's up to you. I don't know. We could wait till 12:15.
Okay. I mean, it's being recorded too, so.
That's true.
Yeah.
Yeah, whatever.
Okay, I'll just
I
start.
say go for it.
Woo!
Go for it.
Okay, today we're going to be talking about, can you say it? You pronounce it correctly, Michael, and I don't.
Reprex.
Reprex, which stands for reproducible example. I always want to call it Reprex, like reproducible and example, but since the R's in there, you have to say it Reprex. Reprex. And basically this is, I'm going to be teaching you the minimum amount of things that you have to do to create a reproducible example, and this will allow other people to help you troubleshoot your code. If you're sending one of these out to an email list like the Davis R users group, generally if you miss something, no one's going to bite your head off. They might send you a gentle reminder that hey, maybe you didn't do this little piece or that little piece. If you do this on a place like StackOverflow, someone might bite your head off. So just be aware that could happen to you when you're making your own reproducible examples. So wall of text, but what is a minimum reproducible example? Basically, it's all of the components that you need so that somebody can reproduce the error that you made in your code, therefore helping you troubleshoot and solve what's going on. So at first, you need a minimal data set. So if you are running something, let's say you're running random forests, and you have 150 samples by 6,000 observations. Actually, it would be transposed, so 6,000 variables by 150 samples. And this takes you 45 minutes to run, and then you hit an error. Nobody wants to download your full data set onto their computer and then run it and wait the 45 minutes to get that same error. They want to run it maybe 5 seconds, more like 0.5 seconds, get the error, and then be able to help you. So what you want to do is reduce your data set to a size that still faithfully recreates that error that you're getting, but is small so that it happens more quickly. And it also makes it easier to share, or people can just look at the whole thing on their screen at once. Then you need the minimum runnable code necessary to reproduce the error. So take out all of the fun formatting things that you did to make it just so for your project. Anything that's superfluous, try and get rid of all of that stuff, and then point to the line that actually creates the error. Because you don't want people to have to run a whole bunch of code and get lost in a bunch of sort of not trivial, but trivial for the error things that are going on, because it makes it harder to solve the problem. And there's more sort of thinking up front that needs to be done, which makes it less likely that someone's actually going to want to help you solve the problem. Then you need things like the information that you have in your own environment. So let's say that you're using dplyr and that's creating a problem. We want to know which version you're using of dplyr. But the other thing that's really helpful is everything else that you have installed on your system. And that's loaded into your library, and that's for 2 reasons. One, sometimes if you have a different package loaded on top of the one that's creating the problem, that could actually be what's causing the problem. So it's important to know that information. And then 2, sometimes packages interact with each other, and if you have the wrong version of one but the correct version of the other, we want to know it all. And then the other thing that can be helpful is sometimes there's like a random distribution at some part of a function that you're running. So setting the seed, meaning that you'll get the same random answer every single time, is helpful for other people so that everybody will be on the same page when working through the example. And this was taken from someone named Joris Mays on StackOverflow. I have no idea who that is, but thank you for typing all of this out because I thought it succinctly represented what you should do. If you would like to see his exact post, you can go to StackOverflow to that number right there. I'll leave it up for a second just in case anybody's navigating there. And he really quite succinctly outlines everything that you should put into your own reproducible examples. Okay, so producing a minimal data set. We'll go through each of those things that I just talked about, and the first one is our minimal data set. So one thing that I hear a lot when I ask people, especially over the internet, like, hey, can you please share your data set with me? But they say, oh no, my data is precious, I can't share it, which sometimes is them not being open science friendly, and other times they're actually working with like human data or sensitive information, or like in Ryan's case, he has location data for an endangered species that you maybe don't want to share with everybody and their mother. And so R has this cool thing called built-in data sets that you can take advantage of and use those data sets. So if you run this command library help is equal to data sets, you'll get a big screen pop up. This is just the first part of it. I'm going to go to my R session so we can run it together. So library help is equal to data sets. And a new tab will pop up. I'm going to zoom out and sort of rearrange some stuff so that we can go through it. Is that still somewhat readable? Okay. So this is all of the data sets that are just built in automatically or have been attached when you add a package into R. And it tells you, it gives you a sometimes useful and sometimes not useful summary of the different things in these data sets. So for instance, we have DNA, so it's an ELISA, an assay of DNAs. There's pharmacokinetics of something, some drug, effectiveness of insect sprays. So there's all sorts of different data. Some are air passengers is a time series. So a lot of these might, or one of these might fit with your data set. So it might be similar enough that you can use one of these or a part of one of these to reproduce the error that you're getting with your own data. So these can be really helpful because the other thing is people are quite familiar with a lot of these data sets. So for instance, empty cars is one that you see people run examples on all the time. If you take a look at this one, it was data that's extracted from the 1974 Motor Trend US magazine. It's a data frame. And we see that some of the attributes, I guess, that are in this data frame, actually, is this a matrix?
Okay.
No, it's a data frame. The help file tells us right there that it's a data frame. I didn't even have to look myself. There's miles per gallon, there's a number of cylinders, displacement, there's all sorts of other information in there. So this one's useful because it has both numbers and factors or characters in its data frame that you could use. So if we take a look at it, it looks like this. That's part of it at least. Okay. Then there's other ones that are popular as well. So for instance, iris, people use this one a lot as too. And if we take a look at this one, it has things like sepal length and species, all for a bunch of different iris flowers. So those are two really common data sets that you'll see people make a reproducible example out of because they're built into R, they're small, and people are familiar with them. But you're not always going to get errors with the data frame, so it's also helpful to know how to make a vector. So you can use some of the built-in functions in R to create some of these vectors. So for instance, if you want different types of distributions, you can use R norm, R unif, uniform. If you need something that's random, there's functions for that as well. And having these laid out as a reference is sometimes helpful because when you're staring an error in the face, it can be kind of daunting to then go and recreate a data set to make it with. But if you have some of them written down ahead of time, it's nice because they're right there and you don't have to think about it. Same thing for a matrix. You can use R's built-in function and create a matrix to match or a smaller portion of your data. Or if you actually decide that your data is not precious and it's just easier to recreate the error with your own data, using things like head or subset or the subsetting brackets indices is useful to make it smaller. So those are all fair game to use. And then formatting this data can also be really helpful. So there's this function in R called dput. So for instance, if we take iris, we run head on iris, getting the first 4 rows, and then we put it in dput, it prints out like this. So it's already formatted so that somebody else could use this. So you could copy and paste this into your reproducible example. And then even though it's kind of hard for you to read, this is easy for somebody else to then go and make this exact same data frame as you. We can also do that if you have a factor. One thing that's annoying with a factor is that there's a memory of all the other levels that have been created. So for instance, if we took iris, there would have been in species, usually there's 3 species in there, Setosa, Virginica, and anybody remember? Doesn't actually matter. Versicolor. But if you take the head of it, the ones in the first few rows are Setosa. So you don't really want that memory of the other 2 levels of the factor. So you might want to say drop levels and then run dput on that. And you'll get a more clean output that recapitulates the data that you're working with. You can also do this with things like in the tidyverse, but you have to run as data frame first because there's some weird formatting things that otherwise won't work. Or if nothing else is working, the other thing that you can do is lay it out like this, where it becomes a table, and then you can use read table to read that object into R. So this is a good size for what your reproducible example data set should be working with. So just a few lines, a few columns. If this is enough to create the error, that's what you want to strive for. Okay, questions about that before we move on to minimal code? Or additions, if other people have tips and tricks. Okay, so for minimal code, you first want to make sure that the data is already provided. So that was what we just were talking about with your minimum data set, but having that as part of the code. It's really important that nobody has to go and create the data to make your code produce an error. You want to locate the line of the code that's causing the problem so that someone else doesn't have to guess what that is. And then if there's other sorts of extraneous information, so for instance, if the error is caused because you're using a function in dplyr, you want to write library dplyr at the top of your example so that everybody else knows which libraries are important for you to be using. And then lastly, once you have this all laid out in your code, open a brand new blank R session that's fresh, has nothing loaded, run your reproducible example and make sure you can still get the error. Because sometimes, like if there's conflicts with packages or something, that either the error will go away or you'll realize that you forgot to add a line of code that you need and you'll be able to put it in. The other thing that's really important is that you're asking other people to run the code that you wrote on their computer. So there's a certain level of trust there. You don't want your first line of code to remove all of the files in the directory that they're working in. That would be pretty devastating if somebody was running that, say, for instance, in their home directory in a fresh R session. If you download any files or create any files, you want to remove them after you're done with producing the error. And if you change any sorts of global options, you should put them back to what they were before. Otherwise, people might not want to run your code again. Okay, questions about that? Michael, you have a question face.
If you go back over the, like, what would be an example of producing connections of file, or like what do you envision having, how this would sort of go?
Right, so let's say that I need to
just, I mean, just like pseudocode or just sort of what it would look like, so you.
Download a CSV from open source,
Okay,
from like website.
Yeah. And then I decide to save it as test.csv. No, that doesn't. Does anybody know the code to remove a file from your desk or from the directory that you're in? It is unlink. It is unlink. That's a stupid command.
It is.
Right. So, for instance, if there was a really nice file already, it would probably be pretty bad form to download an open source CSV instead of just recreating it. But I'm not sure like when exactly it would be a good idea to download a file. But if you did do that,
Yeah.
Remove it.
Okay.
Yeah. So maybe just don't do that at
Or
all.
read it, I was gonna say, you could also read it indirectly into your environment for the example.
Yeah.
Or actually
Yeah.
save it.
Yeah.
But yeah,
I was just thinking about like, what if the code that you're trying to run, you're trying to figure out something's breaking and you think it has something to do with your directory structure? Like that you have that you're interacting with multiple folders, multiple files, and then that is what's causing the problem.
Yeah, I mean, at that point, you can just try and recreate your environment for people. So with things like, oops, list all of the files that are in your directory.
and as you were saying, and Jenny Bryan and others have said, when you start trying to recreate your problem, you typically solve it. Or
Yeah.
see, particularly for something like that, that's your file or folder structure or something like that.
Yeah.
You may actually identify the issue.
Yeah.
But yeah, I know she and others have specifically said you should always, your reproducible example should always leave, like.
Leave no trace.
No trace, right, yeah, like, you should be able to run it and not have to worry about anything being changed on your.
Yeah. Yeah. Okay, other questions about that? Okay, so providing other information. You can get information about a package by running the function package version. This will give you the version of just one package, which is fine, especially if the thing that's causing your problem is one specific package. This calls it out, makes it really clear. No one has to search for it. It pops on the screen to them that I am using version 1.2 to knit my R markdown. But session info has everything. So it's the version of R that I'm running, which is horribly outdated. Whoops. But I'm running Mac OS on this or Sierra on this laptop. It has my text encoding, different base packages that are attached, and then all of my other packages and versions. So let's run this as well because it'll look slightly different or more verbose, I guess, in my R session. So if I run session info, it prints out to the screen down here. And then we can see that the only libraries that I loaded myself are these three up here. But then, and there's the versions appended to them. But then these all got carried along as well with their versions too. And here's the other information that was up top there. And the other thing that can be really helpful, or another thing to note with this, is if you see that you're running For instance, dplyr version 0.7.8. I'm pretty sure we're on 0.7.9 now. So you can check that against what the current version is, and then you can upgrade your package on your local configuration, rerun your code, see if you still get an error. Because a lot of times these are known errors that you're encountering, and they'll have already been fixed in updated versions. Okay.
Is the best way to see if you have the most up-to-date version just Googling it, or is there a way?
Yeah, let's see. I'll show you how I do it, but let's try and just Google it. So if you go on to CRAN, okay, it'll tell you the version up here. Yeah, so going on to CRAN or bioconductor is usually the best way. Oops. Other questions about that? Okay. And you might say that this is so much work, but so is asking somebody to find the solution to the error that you're getting. So if you can make it as easy for them as possible, then you are more likely to get a solution and have somebody that's happy to be answering your question or fixing your error because it's easy for them to do so. So when should you use one of these? Definitely when you're posting a question onto StackOverflow, it's really important to do that. Again, because not everyone is always the nicest if you don't do that, and nobody would want to encounter those grumpy people accidentally while making a mistake like this. Another time that it's really important is if you find an error message, you Google it, you can't find the solution, you can post an issue on GitHub to a lot of packages, and you need all of the information about versions and that sort of thing when you do that, so that people can then go and either say, oh no, that's already been solved, or solve the issue for you and then update the package. And then also, just whenever you're asking questions over Slack or email, you should use one of these as well. And here are some other links to resources. Most of them I think are written by Jenny Bryan. She has some really great tips, do's and don'ts. And she also wrote a little package called Reprex that I'm going to show you right now. I don't actually like it that much, but I think it is a really nice way to check and make sure that you're getting, that you formatted things correctly and that you set things up nicely. Okay, so let's see. If you don't have it installed, you can install Reprex with install.packages, and then you call it into your environment with library. And then let's say that I have this piece of code here. So I'm working with Iris. I'm using dplyr, and I want to filter to anything that has a sepal length greater than 6. And then of the things that have a sepal length greater than 6, I want to select only species Setosa. So if I run this right now, I get error, object species not found. Okay, I don't understand what that means. I want to post this to my lab Slack or to the Davis R users group email list. So I'm going to highlight the code that's giving me a problem, including with the packages that I used. And then I'm going to copy it to my clipboard. And then if I come down to my console and run the function Reprex, we see that over here in my viewfinder, there's now this new little log that has all of the code that would be run. So the first thing is the attachment message that I get from running library dplyr. It says, warning, dplyr was built under R version 3.4.4. That's my first problem. I should probably upgrade my R if I'm getting an error. And then it tells me which packages are or what functions from different packages are masked. And then I have the code that I actually ran and the error message. And all of this is outlined nicely so that my code in and of itself is its nice little own block, and then everything else is commented out. So I could copy and paste this somewhere, and somebody else could run it without having to navigate what's an error, what's not. It's all ready to go. I think the reason that I don't like this is because it's unintuitive to me that there's a clicking part instead of it all being type-based, but I probably should just be grateful that it exists instead of nitpicking it. So it can be a handy little tool to help you with formatting things. Questions about that?
Can you share the last bit of code again?
This only works once I have this copied to my clipboard. Otherwise, it's going to run on the last thing that you copied to your clipboard and probably get pretty confused because it might be like an internet link or something like that. Or 5 pages of a manuscript you just wrote. Okay, and that is a reproducible example. Any questions about reproducible examples at all? Anything I didn't cover? Yes.
So if you are trying to make, I guess like example data that fits the error that you're getting, but you have no idea what the error means, like what would be a
What do you
good
do?
starting point? Not scenario, maybe.
Yeah.
Where to start.
So, okay. Recently, I was running random forests, and my data was 150 samples by 6,000 observations. Wow, funny that I brought this up earlier in this conversation. And I was getting an error, and it was taking 45 minutes to run, and it was incredibly annoying. And so the first thing that I did was I didn't even run head of my data because at that point I had 6,000 columns, but I knew that all of my columns were numerical except for the last one. And it was character, but I didn't know whether it was character or factor, and I couldn't remember which it was supposed to be. So the first thing I did is I subset to like the first 10 samples and the last 10 columns, because I knew that's where the problem was, and all of my numerical data was being treated the same. So then I reran it on that and was able to get the error, but at that point I could visualize every part that was causing the problem, and I still got the same error message. And then it was easier for me to say, like, okay, if I run summary on this, what's the output? Like, what's the column header? Should it be a function? Or sorry, should it be a factor? But that was sort of like the first clue, is that only one column was different from the rest of them. So trying to narrow it down that way, or even just running head, fine, you have 6,000 columns, but if you can get rid of all of the rows except for the first 5 and still get it, like, that's a step in the right direction.
Cool, thanks.
I'm assuming that you're working with a matrix or a data frame most of the time.
So,
And often, I would add to that that if you get an error message, one of the best things you can do is Google it.
Yeah.
Like literally paste it in and see what you get. And, you know, it does take some culling through StackOverflow or elsewhere, but
Yeah.
I typically do that. It's particularly if it's one that I'm not familiar with.
Yeah.
And then that gives me a little bit better of an idea of like either just subset and try to recreate that same thing, or if it's something like even more egregious where you're like, well, that's not gonna happen, then I need to do more Googling or more, you know, like back to step 1. But
Yeah.
often that's what I do to sort of see like where is the error occurring.
Absolutely. I do the exact same thing. Always Google the error message.
Yeah.
You can usually leave out part of it, but you can start by Googling the whole thing and then narrow it down to the interesting bits depending on what garbage you do or don't get back.
Right. Cool. Thank you, Jim.